Today we would like to present our group innovation project titled From Idea to Action, Drain Cut AI, Smart Flood and Waste Detection Drain. This project is part of the course BTM547, Innovative Thinking Strategies, and it focuses on developing a smart solution to address real urban problems, especially drainage, blockage, and urban flooding. Our project introduced Drain Cut AI, an intelligent system designed to detect waste, monitor water levels, and prevent flash floods using smart technology. Before that, I would like to introduce my team members. And now we have Nur Atira Nabiha binti Muhammad Norli, Hani Syaira binti Talha, Nur Maisara Nabila binti Abdul Malik, Yasmin binti Halimuddin, and me myself, Nur Sofia binti Muhammad Fauzi. So I will continue with introduction of this innovation. Urban flooding and drainage blockage are becoming more common, especially in rapidly developing cities. This usually happens because of poor waste disposal and drainage systems that are only maintained after problems occur. To address this issue, we propose Drain Cut AI, a smart solar-powered drainage system that uses AI and IoT to monitor water levels and detect waste in real time. By providing early warnings to local authorities, Drain Cut AI helps prevent flash floods, reduce maintenance costs, and create a safer and cleaner urban environment.
Now, for these sections, I will explain our initial works focusing on driving the empathy. First, let me talk about the issues we want to explore. So, the main problem is blocked drainage system caused by rubbish, rivers, and plastic waste. These blockages often lead to flash flood on roads and in residential areas, especially during a heavy rains. So, when the drains are blocked, so water cannot flow properly, it causing a flooding and making manual drain cleaning slow and risky. So next, the reasons why we want to explore this issue. So this problem affects public safety because flooded road can cause accidents. It also causes traffic disruptions and property damage to nearby houses and shops. So in addition, dirty floodwater can create a health risk and the cost of repair after flooding is very high. So currently, the drainage system usually wreck after flooding happens, not before, which make it inefficient. Moving on to the who we will meet. So we will meet a residents living near a roadside drains, especially those in flood-prone areas. We will also talk to municipal workers who are responsible for a drain maintenance. In addition, small business owners near flood-prone area are included because of flooding affect their daily operations. Now, for the questions we will ask about their experience with drain blockages or flooding in the area. We will also ask how often they notice rubbish, rivers, or plastic waste clogging roadside drains. Finally, we want to understand how flood affect their daily activities, safety, and property. Lastly, the places we want to go for observations. So, we plan to observe residential area near main roads, roadside near night market or stall, and area with poor drainage and heavy rainfall. So, this location helps us understand the real problems faced by the community. For interview questions, we have 3 questions to ask to Ms. Susanna. First question is, we want to ask Ms. Susanna to describe her experience with a drain blockages or flooding in her area. So second question is, how often do Ms. Susanna notice rubbish, rivers, or plastic waste clogging roadside drains? And the last question is, what problem do floods cause to Ms. Susanna daily activities, safety, or a property? So next, I will explain the final empathy stage of our initial works. So based on our observations and interview, we identified the main issue. There are frequent drain blockages caused by rubbish, rivers, and plastic waste. These blockages lead to flooding in residential and roadside area, especially during a heavy rainfall. So when a drain overflow, they affect nearby roads and houses and disturb daily life. Now, let me explain why this issue is important to explore. So flooding happen often in residential area and interrupt a daily activity for community. So blocked drain create a safety risk such as slippery roads and accidents. So in addition, dirty floodwater can damage property and cause health problems. Therefore, a preventive solution is needed to reduce flooding and improve public safety. So next, who we will meet. Our primary user are residents living in a flood-prone residential area, and our secondary user are local authorities or city workers who are responsible for drain maintenance. These users are directly affected by the problems and involved in managing drainage system. So moving on to the questions we will ask. We will ask users to describe their experience with drain blockaging and flooding. We will also ask how often they notice rubbish, leaves or plastic waste clogging roadside drains. And finally, we want to understand how flooding affects their daily activity, safety, and property. So lastly, the places we want to observe. We will observe residential areas that frequently experience of the flooding. We will also study roadside or sideway drains near houses. In addition, we will observe drains where rubbish and waste often accumulate.
Next part is the planning for the groundwork. The first one is tension, contradict and surprise. Mrs. Susanna is a resident living near roadside drains and often faces blocked drains during heavy rain. These blockages causes flooding, make it hard to walk around and affect daily life. Manual drain cleaning is also irregular, which makes the problem worse. She believes that an intelligent system like DrainGuard AI with automated waste removal and timely alerts could help reduce manual cleaning and prevent floods. Surprisingly, she did not know that the system can detect blockages before flooding and works with solar power. She also learned it is safe for children and pedestrians as all moving parts are inside the drain. Next is the POV. Mrs. Susanna lives near roadside drains and often sees them get blocked, especially during heavy rain. She worries about safety, particularly for children and the elderly. She thinks DrainGuard AI is a good solution because it can detect blockages early and help to prevent flooding. This system also reduces the need for manual cleaning, and being solar powered with all moving parts inside the drain is safe for the area. Next part is dream and how might we statement. What can we do to create smart drainage which could identify the blockage at the very beginning, avoid floods and enhance citizen safety even in residential zones, and minimize the necessity of their manual maintenance and work properly with the help of sustainable energy. For this project, our main goal is to develop a smart drainage system that is safe, efficient, and suitable for residential and roadside areas. Based on the interview with Mrs. Susanna, drain blockages and flooding are serious problems during the rainy season, especially for children and pedestrians. The first deliverable is the DrainGuard AI prototype, which uses sensors, AI cameras, and IoT to detect blockages and rising water levels early. This helps prevent floods before they become serious. The second deliverable focuses on safety by reducing open drains and minimizing accidents. The project also reduces the need for manual draining cleaning, saving time and reducing risk for workers. In addition, real-time alerts allow authorities to respond quickly. Lastly, the use of solar energy supports long-term cost savings and environmental sustainability. Next part is the project challenges. One of the main challenges is ensuring early and accurate detection before blockages and rising water levels, especially during heavy rains. Next, design the system to be safe for the children, pedestrians, and pets is also a challenge, as all components must be securely covered and protected. Third, reducing the need for manual drain cleaning requires reliable automation and accurate AI detection. Another challenge is ensuring the system can operate sustainability using solar power even in different weather conditions. Lastly, the system must be durable enough to withstand harsh urban environments such as heavy rains, waste build-up, and daily public use. To measure the success of the DrainGuard AI innovation, several key indicators have been identified. First, the system must be able to detect blockages and rising water levels early to prevent flooding. Next, effective flood prevention and accurate real-time alerts shows that the system performs really well during heavy rain. Reduced manual drain cleaning indicates improved efficiency and lower maintenance risks. Safety is also important, especially for children and pedestrians. Through sealed and secure drain covers, the use of solar power ensures reliable and sustainable operation. High acceptance from residents and local authorities shows trust in the system. For this part, it shows several existing innovations related to drainage and flood management. First, the smart water level sensors system helps monitor water levels but cannot detect risk blockages early. Adding AI can improve prevention. Next, CCTV drain monitoring systems rely on human observation, which is slow. AI automation can make detection faster and more efficient. Traditional drain grids still require manual cleaning, which is risky and time-consuming. Automation and sensors can improve this process. Lastly, flood early warning systems only alert users after water reach a dangerous level. By combining them with smart drains, floods can be prevented earlier. The main problem we are addressing is drain blockages and flash floods, especially during heavy rain. This cause unsafe walking conditions, traffic jams, damage to homes, and increased maintenance costs. Current systems rely on manual cleaning and lack early warnings, so authorities can only respond after flooding occurs. Our solution, DrainGuard AI, is an intelligent drainage system using AI vision, water level sensors, and IoT. It detects blockages and rising water early, automatically collects waste, and alerts local councils. With DrainGuard AI, floods can be prevented, manual cleaning is reduced, urban areas are cleaner and safer, and it contributes to smarter, sustainable cities. Residents often face blocked drains and floods, which makes streets unsafe and stress households. Current drainage systems are slow and rely on manual cleaning, which is not enough. People want early detection and automated systems to prevent problems before they get worse. Drain.ai addressed this by detecting blockages early, preventing floods, and using a safe sealed design. It is solar powered, reduces maintenance, and helps make cities cleaner, safer, and smarter.
Hi, Assalamualaikum. My name is Atira Nabiha. Today I will explain about the other generation of my team members. Number one is Smart Speed Control Zone from Sofia. A smart speed control zone is a road operation technique that incorporates elements like digital sign, sensor technologies, and some technologies that can change the speed restriction level based on the real-time condition. The next idea is Equilin, the idea from Hanis. The idea behind Equilin is based on decreasing stress, especially that expressed by young adults as a result of school as well as employment. It is an innovative idea as it is rather simple while at the same time promoting approach whereby human activity is used for healing the environment. And the next idea is from Maisara, which is smart roadside pedestrian light. The road accidents involving pedestrians mostly occur in area where the lighting condition is not good. The traffic flow is heavy and there's no traffic signal. A driver may fail to notice the pedestrian that trying to cross over the road at night or during bad weather. The next idea is Drain AI Guide, the idea from Yasmin. Drain AI Guide is smart drainage system that use AI sensor and IoT to detect blockage, raising water level, and waste will up in drains. This idea is preventing floods before they happen. And the last idea is from me, which is autonomous smart drain infrastructure, or it's called as ASDI. This idea is use automated mechanical components, AI, and IoT to control the stormwater and stop urban flooding without need the human involvement. Next is idea evaluation of four ideas that not be selected. Number one is smart speed control zone. The system is costly to install and maintain due to the high technology involved. In addition, the system requires pressure sensor. If the technology fails, the system will fail too. Moreover, the constant changes in speed limit may cause confusion among the driver. Next is Ecolane. Ecolane has become benefits such as reducing stress and increasing exposure to greenery. However, these benefits are indirect and hard to measure. The long-term success of Ecolane depends on public use and regular maintenance that impact the long term to be seen. Next is smart roadside pedestrian light. One possible issue is high cost of installation and maintenance that may be difficult for local authority to afford. The last one is autonomous smart drain infrastructure. which is the issue is high maintenance and implementation costs. It is an expensive long-term commitment due to the high initial cost of IoT sensor and mechanical gates as well as the challenges of maintaining electronics in corrosive subterranean condition. And then the autonomous gates may malfunction or behave erratically due to the software bug, hack, or power outage during the storm. Next is idea expansion. Our group chose Drain Guard AI because it effectively prevents urban flooding while using AI and real-time monitoring. Research and stakeholder feedback show a strong need for safe, durable, low maintenance, and sustainable drainage system. DrainGuard AI is solar-powered smart drain with AI sensor that detect blockage and rising water level. When a blockage occurs, the system automatically diverts water and sends instant alerts to local authorities. It also includes tamper-proof sensor, modular waste chambers, and fail-safe mechanism to ensure continuous water flow. Overall, DreamGuard AI provides a smart, reliable, and sustainable solution that improve public safety, reduce maintenance costs, and enhance urban living conditions.
Here, we have the Drain Guard AI, a smart drainage system designed to prevent urban flooding and make streets safer. At the surface, there's a reinforced anti-slip grate that stops debris and protects pedestrians. Underneath, AI sensor and water level detectors constantly monitor the drain for blockage or rising water. When a problem is detected, the automatic mechanical gate redirects water to prevent flooding, while the modular waste chamber collects debris, making maintenance quick and easy. The system is solar powered and sends real-time alerts to city authorities, so action can be taken before any flooding occurs. In short, this system transforms a regular drain into a smart, safe, and sustainable solution for modern cities. This is Rahim. He is 42 years old and works as a senior municipal maintenance officer in Johor Bahru. He managed drainage system in flood-prone areas and has over 15 years of experience. Rahim faced several challenges. Drains often clog suddenly, causing floods. Manual inspections take a lot of time, manpower is limited, and power outages can affect traditional system during storm. With DrainGuard AI, Rahim's work becomes much easier. He can monitor drain status in real time through a dashboard, receive instant alerts when blockage or rising water are detected, and view data on flood-prone areas. He can also schedule maintenance efficiently and the system continues operating even during power outages because it's solar power. Overall, DrainGuard AI helps Rahim prevent flooding proactively, reduce manual work, and protects the city, its residents, and infrastructure efficiently.
Next is the rapid prototype. Here we have the rapid prototype of DrainGuard AI. This small model helps us test how the system works before building the real one. The sensor detects rising water and blockage, and the automatic gate redirect water to prevent the flooding. The waste chamber collects debris and easy to remove. It's making the maintenance faster. The system is solar powered and can send real-time alerts to city authorities. This prototype show that our smart drain is practical, safe, and ready for full-scale development. Next, we have business model canvas, or we call as BMC. We have key partners, key activities, value proposition, customer relationships, customer segment, channels, cost structure, and the last one is revenue streams. Key partner have city council and municipal authorities. We have also the urban planning departments, drainage and infrastructure contractors, and key activity, we have the design and development of AI-powered smart drainage system, manufacturing and assembly of drain guard AI units. For the value proposition, we have proactive flood prevention through the real-time detection and automated responses. And customer relationship, we have long-term partnership with city council and municipal bodies. For the customer segment, city council and municipal governments, we also have smart city developers, residential area management bodies, industrial and commercial zone operators. And for the channels, we have direct sales, government and municipal authorities. And we have the cost structure, which is research and development, AI software and system testing. And the last one is revenue streams, which is the sale of drone guard AI units to municipalities and installation. And for the revenue stream, we also have the annual maintenance and services contracts, subscription fees for the data analytics to monitor the dashboard.
Next, I will explain the novelty of Drain Guard AI. Drain Guard AI is different from the traditional drainage system because it combines AI, IoT, and automated mechanical system in one solution. Unlike normal drains that only monitor water level, this system uses AI vision sensors to detect different types of waste, such as plastic, leaves, and debris. This allows the system to identify the real cause of blockage. Another unique feature is that Drain Guard AI can react automatically. When waste is detected, an internal mechanical gate will redirect the waste into a holding container before flooding occurs. This makes Drain Guard AI a preventive system rather than a reactive one. It also reduces manual inspection, improves public safety, and supports sustainable smart city development. To conclude, this project focuses on the problem of drainage blockage and flash floods in roadside and residential areas, especially during heavy rainfall. From observations and user-centered analysis, traditional drainage systems are found to be reactive as they depend on manual inspection after flooding occurs. This situation increases safety risks, maintenance costs, and discomfort to the public. DrainCut AI is proposed as a smart and proactive solution. By using AI, IoT, and automated system, the drain can detect waste buildup and rising water levels at an early stage. This helps prevent floods, reduce property damage, and minimize manual drain cleaning. In addition, the use of solar power supports environmental sustainability and long-term cost saving. The cover and child-friendly design also make it safe to be installed in public areas. Overall, DrainCut AI show how innovative technology can solve real urban problems and contribute to cleaner, safer, and smarter cities in the future.